Hi, I am Seth Rotenberger, and today I am going to show you how to maximize your workflow when using NX's Topology Optimization. I currently have a linkage in the graphics window. I renamed a study, and to make sure Maximize Stiffness is selected. The linkage body will be my design space. The library materials has many different materials to choose from. I'm selecting steel for this linkage. I would like the part to be symmetric, and to do that, I add a planar shape constraint, which adds a plane between the two outside edges. We need to shell these pins so that the part can easily integrate into an assembly. One end of the linkage is fixed. The other side has a downwards force of 10,000 newtons and a bearing load of 10,000 newtons in the y direction. Finally, let's constrain the mass to 1 kilogram. After the study has run, we can view both the displacement and the stress of the object. We're going to keep repeating the studies with varying masses to better understand how this stress changes. After cloning the study, the accuracy needs to be increased to account for the decrease in member size due to the smaller mass. The only other change that needs to be made is to decrease the mass to 0.8 kilograms. When we compare the two studies to each other, it is clear that the smaller mass has a larger displacement. And a larger stress. Let's repeat this process again to see how an even smaller mass affects the design. The accuracy is increased again, and the mass is decreased to 0.6 kilograms. The results of the 0.6 kilogram and 0.8 kilogram studies again show a larger stress and a larger displacement on the model with the smaller mass. None of these different studies that we ran have a particularly desirable amount of stress. To solve this, we are going to make another study, but this time with a minimum mass objective. And a maximum stress limit equal to 90% of the yield strength. We can clearly see that using the minimize mass objective has changed both the design of the model and the stress. The displacement values have also changed. We can use the result report to view and compare the results of the different studies. We can clearly see how the stress changes between the stiffness studies, and we can also view the actual mass of the stress study. Let's recap what you have seen. I created a topology optimization study based on a linkage with an added force and a load. I then maximized the stiffness with decreasing masses to observe the change in the model. You then saw me make a minimized mass study with a stress constraint and then view all of these different results using the result report. I want to thank you for your time and attention.